Okay, so in this lecture, I'm just going to discuss techniques for order preference by similarity to ideal solution. In short, we just pronounce it Topsis. So Topsis stands for technique for order preference by similarity to ideal solution. So Topsis is a very popular and very famous multi-criteria decision-making tools. Some researchers consider that this technique is much more powerful than analytical hierarchy process because the structure and the formulation of the distance which they calculate is a little bit different from the analytical hierarchy process. In this method, two artificial alternatives are hypothesized. One is ideal alternative and the other one is the negative ideal alternative. Ideal alternative, one which has the best attribute. So means sometimes we want to compare different alternatives, but some alternative attributes are positive and some alternative attributes are negative. For example, maximum, we mean, for example, if we want to visit some specific area, definitely we want to get more benefit. We want to entertain much more. We want to enjoy much more. And the cost of that place, of that hotel, or that mean transportation is much lower. So I mean, this is the ideal alternative. We want to spend holidays in which place where there is too much entertainment, when there is a lot of benefits, when there is a lot of entertainment and the cost is very low. So this is the ideal alternative. So everyone, because this is in the nature of every human being, they spend less money and enjoy more. The other one is the negative ideal alternative, one which has the worst attribute values. Worst attributes values, for example, minimum benefit and maximum cost attribute. Some alternative are much costly and the benefit are very minor. So now these are two alternatives, actually mean everyone want to choose this one. Now we will calculate that in different alternative, in different criteria, in the multi-criteria decision environment, which alternative will be ideal. So in order to calculate this, we will calculate to select the alternative that is closest to the ideal solution and farthest from the negative ideal solution. Why? Because we don't like maximum cost, we like maximum benefit. So how to get a solution, how to get an alternative which give us the ideal, which give us more maximum benefit, which reduce our cost. So basically Topsis can do this for you. Topsis select the alternative that is closest to the ideal solution and farthest from the negative ideal solution. So the origin and history, first time developed by Kwang Soon Yoon and Wang Ching Lei in 1980. Basically they developed this technique in their PhD thesis. The Yoon case system selection by multiple attribute decision making. This is the title of their PhD thesis. And the Yoon K and C Huang Topsis technique for order by similarity to ideal solution, which first time they pronounce it with the Topsis, first time they give this name, a multiple attribute is making a paper to, and that paper was published in 1981. So first time they developed this technique and they basically use the basic concept of this technique. Basically they use the Euclidean distance and Manhattan distance formula. I will discuss that, but I don't want to go into that detail to explore that formula because this is out of the scope of this course. The chosen alternative should have the shortest distance from the ideal solution. So I have already discussed which one will be the ideal solution, that where the maximum benefit and minimum cost. So this technique will give you the chosen alternative. This will calculate that alternative which have the shortest distance from the ideal solution and it is much far away from the negative ideal solution. And which one will be the negative solution? Where there is minimum benefit and maximum cost. So this is basically a sphere ellipsoid. This is a sphere. In this pair there are different points. Let's suppose A1 and A2. This is our ideal solution and this is our negative ideal solution. So mean visually you wouldn't be able that which point. So visually this point is looking nearest to this one, but this is not because this is a sphere. It is moving. This is a sphere. We will not be able. So basically Topsis can calculate this for us. So there are different alternatives. Now we want that which alternative is the nearest to the ideal solution and which alternative is farthest from the ideal solution. It's mean it's near to the negative solution. It is very difficult to justify the selection of A1 or A2 in this example, but Topsis can help us. that which one will be the nearest to the ideal solution, which is this one, and which one will be the near to the negative ideal solution, and this will be the farthest one from the ideal solution. So before going to discuss the mathematical interpretation of Topsis, I want to discuss a very simple example. Otherwise, if I start the mathematical interpretation, then it will be difficult for you. So I will discuss the mathematical interpretation of this Topsis in the later stages. For example, Ali wants to go on a vacation. He has three options: Kalam, Mari, and Hunza. Okay, how to decide? Yes, every place have some specific criteria. These are three alternatives basically. Now, there are some criteria we need to have. So Ali have, let's suppose, Ali have 4 criteria. Entertainment, he want to entertain too much. He want to get maximum facilities. He want to spend much on accommodation. He want to spend less on accommodation. He want to spend less on travel costs. So in these criteria, 2 are related to the benefit criteria, where he want maximum benefit, and 2 are related to the cost attribute criteria, where he want less, minimum cost. So each option can be evaluated. Now we have 3 alternatives: Kalam, Mari, and Hunza, and Ali have 4 different criteria. So selecting a source of information, library, internet, involves various criteria. So such as reliability of information, time of gathering information, cost of acquiring information. So this example, let's suppose, and the previous example, because 3 different alternatives and he have 4 different criteria. Now this is an example of multi-criteria, because he have different criteria and he have 3 different alternatives. So this is a MCDM problem. So as we have already discussed, that alternative are the option which are to be evaluated for selection of the best. So in the current example, we have Ali have 3 different alternatives: Kalam, Mari, and Hunza. So criteria for attribute, these will impact the selection of alternative. For vacation problem, entertainment, facilities, travel cost, accommodation cost. So these are 4 criteria which Ali want to consider. Once again, as we have already discussed in the AHP in the previous video, that all the criteria will be complete. It is important to ensure that all of the important criteria are included. So in order to solve that which alternative, Kalam is best, Mari is best, or Hunza is best, we need to consider all the important criteria. There should be no redundancy. There should be no repetition in principal criteria that have been judged relatively unimportant, or to be duplicate should be removed at a very early stage. So there should be no redundancy, there should be no duplicate criteria. Operationality, it is important that each alternative can be judged against each criterion. So this is operationality, that you consider, you compare each alternative with this criteria. Entertainment, you need to compare this Kalam with entertainment, Kalam with facilities, Kalam with the travel cost, and Kalam with the accommodation cost. Similarly, every alternative you need to compare. This is operationality. The other important characteristic is the independency. All the criteria should be independent. All the criteria should be mutually exclusive, not mutually inclusive. Then we will assign weights. These estimate relative importance of criteria. So each attribute is given certain points on 0 to 1. So as we have already assigned weights in the AHP, similarly we will be considering different scales. For example, Likert scale, 39-point scale, or mean you can also assign from 0 to 100 rating scale, or you can use Likert scale by term of expert or decision maker. So now if you want to consider this problem, and if you want to consult from decision maker, from those who have already visited those areas, now you will collect data. So how you will collect data? You need to design a questionnaire, then you need to design question, then you will collect the data. For example, in our case, we have 3 different decision makers. These are experts who are decision makers. These are experts who are assigned with the task of weighting each attribute. So in our case, attributes are the criteria. There can be n number of decision makers. So you can also include, in this example, we have only include Feroz, Amin, and Saad, 3 decision makers. Let's suppose you including 20 or 50 or 100 decision makers. Then what you need to do, I will tell you. But before going to that, in this example, you need to understand that these are 2 benefit criteria: entertainment and facilities. Travel cost, accommodation cost are the 2 cost related criteria. So we will assign a rating from 1 to 10. 10 will be assigned to very good, 9 will be another good, so mean it will be reducing, it will be a descending order. 1, it's mean you assigning a very low rate to this benefit criteria. Similarly, this is also a benefit criteria, so we will assign 10 to very good, 9, 8, and 1 will be, that mean you assigning a very slight, very low rate to this criteria. The travel cost, so mean rating scale, you need to remember different researchers use different scaling, so don't rely totally on this one, okay? Maybe some other use Likert scale, maybe someone use some other type scale, maybe someone use from 0 to 100. So travel cost, 10 will be low, 1 will be very high. So in the cost attribute criteria, when you assigning weight, so mean heaviest weight will be, mean heaviest digit will be considered as low and lowest digit will be considered as a very high. So in this example, very high. Similarly, this is also a cost attribute. So once again, the same thing. So now we want to construct the data, we want to consider to ask from the expert. So let's suppose the first criteria is entertainment. So Feroz assigning 4. So mean 4 mean it's in the middle. 10 will be very good, but Feroz assign to entertainment 4. Amin assigning very low weight to entertainment. Saad assigning a little bit high score. And this is attribute weights. So now you need to calculate the average of this 4 plus 2 plus 6. So it is 12. 12 divided by 3 because we have 3 decision makers. So 4. Facilities. Feroz assigned 2. Amin assigned 3 and Saad assigned 1. So 3 plus 2 plus 1, 6. 6 divided by 3, so 2. This is simply travel cost. So Feroz assigned 6, Amin assigning very high. So mean because you need to remember 1 will be very high, 2 will also be, 2 will be much higher than 3, 3 will be much higher than 4. So Saad assigning very low in the term of cost attribute 8, and similarly when you calculate the average, similarly for accommodation, once again you will calculate the average. Now we did this for directly for the criteria. Now we will the decision maker will assign weight related to these criteria. So now these are the criteria, and now decision we will compare this column. So column is our first alternative, a table that is used to objectively make decision about making selection from a range of option. Decision maker rates each attribute of each alternative. So now we taking this column, entertainment in column. So we comparing each alternative with each criteria. Column, Feroz assigning 10, Amin assigning 8, and Saad assigning 9. Once again, we need to calculate the average. So 10 plus 8 plus 9, 27. 27 divided by 3, 9. Facilities. So facilities comparing to the column. So 7, Feroz assigning 7, Amin assigning 8, Saad assigning 6, and then you will calculate the average. Similarly for travel cost, Feroz assigning travel cost for where? For column. Only column. So in this example, we comparing column with all the criteria, and then we calculate this attribute weights. Similarly for Murray. So Murray is our second alternative. He want to go to Murray. Now we want to construct a decision matrix for this. So Murray compare with entertainment. So Feroz assigning 9, Amin assigning 6, and Saad assigning 9. Once again, you need to calculate the average. Similarly for facilities, so we will calculate attributes weight for Murray. Similarly, we will calculate attributes weight for Hunza, and all the 3 decision maker assigning for Hunza against each criteria: entertainment, facilities, travel cost, accommodation cost. So we will calculate these attribute weights. So we calculate these attributes 9, 7, 6, 7 for column, 8, 7, 9, 6 for Murray, and 7, 8, 6, 6 for Hunza. So this is our matrix: column, Murray, Hunza. So column, we have already calculated all these, so I don't want to repeat it again and again for all these criteria. So this is our decision matrix. Okay, so you can see these are already we have calculated. So I just bring it that you understand that from where I construct this decision matrix. So basically we compare column against each alternative, we compare Murray against each alternative, and Hunza against, and we ask from these 3 different decision maker. So you can see this. Okay, now we will start standardizing. So how we will do the standardization? Standardize the decision matrix. So now we will construct a standardized decision matrix. This strip transforms various attributes dimension into non-dimensional attributes which allow comparison across criteria. For standardizing, each column of decision matrix is divided by root of sum of square of respective column. So basically this is our this matrix, decision matrix. What we will do now in the next step, we will for standard each column of decision matrix is divided by root sum of square. So decision matrix, each column you can see 9, so criteria, okay, each column of decision matrix divided by root sum of square of respective column. Okay, so this column 9 square plus 8 square plus 7 square and take the square root. We are now doing standardization. So when you take the square, you will get this. Similarly for facilities, square of this, and you will get this 6 square plus 9 square plus 6 square and taking the square root. So this is the decision matrix. When you do this, it is called standardized weights. Okay, so after standardized weights, what we will do, we will construct a normalization. So you can see in the previous slide we have calculated all these 13.9. How we calculate this? 9 square plus 8 square plus 7 square and square root. So this. Now you need to divide with the standardized weight the standardized matrix each element with the standardized weights. So 9 divided by 13.93. Okay, and then you will get this one. Similarly, 8 divided by this, you will get this one. 7 divided by 13.93. Similarly, 7 divided by 12.73. 7 divided by 12.73. 8 divided by 12.73. Similarly, you will divide 6 divided by this, 9 divided by this, 6 divided by this, and 7 divided by this. Make sure that this process is for the criteria. Okay, the criteria column. If the criteria are in the column, then you need to do 9 square plus 7 square plus 6 square plus 7 square and take the square root. Okay, so you not need to be confused. If the alternative are in this column, then you need to do the standardization. You need to do 9 square plus 7 square. But now in this case, criteria are in the rows and against each alternative. So you will do this one. Okay, so in this way you will calculate the normalized matrix. So you can see this is our standardized decision matrix or normalized decision matrix. So you need to remember. Now in the next step, when you calculate this, we will multiply the criteria weights to this standardized matrix. So you remember in the start we get information, or mean we get survey, we conduct a survey, we collect information from 3 decision makers and they assign weights to the criteria. So Pharaohs assign 4. If you remember in the start slides, entertainment 4, I mean 2, 6, facilities 2, 3. So now these are the attribute weights. Now what we need to do? Construct weight standardization matrix by multiplying attribute weight to each rating. Now I will show you. Now you will multiply this with this. Okay, so how you will do this? You can see 4 multiplied by this 0.6. So this is the attribute weights. Then 4, in the next 4 into this, you will get this. 4 into this, you will get this. Similarly, 2 into multiply by 0.55, 2 multiply by 0.55, 2 multiply by 0.63. So you will get this one. So you can see 2. How we will get this? By this way. This is weighted standardized decision matrix. Okay. So when you construct this, now we need to use the Euclidean or Manhattan distance formula, which we will be using for Topsis in order to know that which alternative is the farthest from the ideal solution and which alternative is nearest to the ideal solution. So in the previous slides, when we construct this, this is our weighted standardized decision matrix. Now in the next step, determine ideal solution and negative ideal solution. So how we will get the ideal solution and negative ideal solution? You need to calculate maximum from this, because we are looking for the ideal solution. Which one in the entertainment criteria, which one is the maximum? In the facilities criteria, which one is the maximum? In the travel cost, which one is the maximum? So this is the ideal solution. Now one thing you need to remember, for positive ideal solution, we will be taking, this is very important point, you need to remember this, how we get this value. So there are 2 criteria which are benefit attribute criteria and 2 criteria which is cost attribute criteria. Okay, so benefit criteria, we want that we get maximum. So which value is maximum in this one? Which value is maximum in this one? Yes, 2.28. So you can see, sorry, 2.6 is the maximum one. Which one is the maximum in this one? Because entertainment, we want to entertain too much. So benefit criteria, which one will be the ideal solution in this one? 2.6. Similarly, facilities is another benefit criteria. So which one is the maximum one? This one, the red one, 1.26. So this is 1.26. Travel cost. Travel cost, this is the maximum one, but we will be looking the minimum value of this because this is a negative benefit criteria. This is negative criteria, I mean cost attribute criteria. So we will choose the minimum one. So which one is the minimum one? 2.94. Similarly, which one is the minimum one in this one? Because accommodation mean we will be looking for the minimum cost. So which one? 4.4. So these are basically our positive ideal solution. Remember this 2.16, 1.26, 2.94 and 4.44. Now this is the same matrix with this one weighted. We have already calculated weighted standardized decision matrix. Now what you need to do? Determine ideal solution. So we determine the negative ideal solution. So in negative ideal solution, set a minimum value for negative ideal solution. Now you need to choose minimum in which criteria? In the benefit criteria. So which one is the minimum one? 2 is the minimum one. Similarly, facility is also the benefit criteria. You need to choose minimum one. And travel cost, which is cost attribute criteria, we will choose because this is negative ideal solution. So which one is the maximum one? We will choose 4.38. You can see this one, 4.38 is the maximum one. And accommodation cost, we will also choose the maximum one because this is negative ideal solution. So negative ideal solution is an opposite of positive ideal solution. In positive ideal solution, we will be looking maximum from the benefit and minimum from the cost attribute criteria. In the negative ideal solution, which is which is the opposite of ideal solution, we will choose minimum from the benefit attribute criteria and we will choose maximum from the negative ideal solution, the cost attribute criteria. So you can see this is the 5.12, which is maximum, and from travel cost 2.94. So which one is the maximum one? 4.38. So when you calculate this, now we will calculate the ideal solution, and the formula of this I will show you because as I already told you that we will discuss the mathematical formulation at the end of this example. So basically this is the weighted decision matrix, weighted standardized decision matrix. So now the ideal solution, which was the ideal solution values? So you need to remember this. Okay, you need to remember this 2.6, 1.26, 2.94 and 4.4. So you can see now we need to divide. The first was the ideal was 2.6. So you need to subtract 2.6 from the entertainment row. Okay, 2.6 minus 2, and then you need to take square. 2.28 minus 2.6, then you need to take square. 2.0 minus 2.6, then you take the square. Then the second positive ideal solution, which was 1.26. So you need to subtract it from facilities criteria. Which one? 1.26. So 1.26, you can see facilities. 1.1 minus 1.26, 1.1 minus 1.26, 1.26 minus 1, and you need to take square. Similarly, the third one in the positive ideal solution was 2.94. You need to subtract it from travel cost. 2.94 and take the square. Similarly, the last one was 4.4 in the positive ideal solution. Okay, so when you do this, you need to take square. You will get this 0. Why? Because 2.6 minus 2 is 0. 0 taking square 0. So you will get this matrix. Then what you need to do for the now you need to stop for this. Now you need to consider the column because we want to choose which one will be the best one, which one will be the most feasible one. So this plus this plus this plus this, you need to take the square root, or you need to take power 1 by 2. Similarly, for this one you need to take the square root, for this one you need to take the square root, and we will denote this with SI steric. So from this we get 0.74, from this we get 1.48, and from this we get 0.6. So now we only calculate the ideal solution. Now we will calculate negative ideal solution. So the process is much similar than the positive ideal solution. What you will do now, you need to remember this 2, 1.1, 4 points. So 2, you need to subtract 2.6 minus 2, 2.28 minus 2, and 2 minus 2 and square. Similarly, 1.1 minus 1.2, 1.1 minus 1.2, 1.28 minus 1.1, and you need to take the square. So I did the same step. You can see 2.6 minus 2 because 2, 1.1, 4.38 and 5.12 are our negative ideal values. So now you need to subtract from each criteria, okay, not the alternative. Remember, maybe in some research paper, maybe in some slide, criteria will be in the column. So then you need to transform that. You need to 2.6 minus 2, 1 point. So you need to do like this, okay. So in this one, you need to consider these criteria with the row wise. So after that, when you simplify it, you will get, once again, you need to take the square root, the sum of the values of the alternatives. So column 0.36 plus 0 plus 2.07 plus this, taking the square root. Similarly for this, and we will denote this SI, this mean comma, okay. We will denote this. You can also use another notation for notifying or denoting negative ideal solution. The next step is determine relative closeness to ideal solution. So as I already mentioned that in the Euclidean space formula, we want to calculate which point is near to the ideal solution and which point is the farthest from the ideal solution and which point is near to the negative ideal solution. So we calculate this positive ideal solution where we calculate this 0.74, 1.48 and 0.6. Similarly, we also calculate negative ideal solution 1.56, 0.773 and 1.618. So we just put these values. Now you need to add both one. So 0.74 plus 1.56, when you add it, you will get this. And this is the formula. SI, so this is negative ideal solution divided by sum of positive and negative ideal solution. So when you do this, what? 1.56 divided by the sum of this and this. 0.77 negative ideal divided by sum of this and this. Okay. And 1.618 divided by sum of this ideal and negative ideal solution. So the value which you get, it will be considered as a best one. So which one is the best one in this example? So now the Topsis considered that Ali should need to go to Hunza. Why? Because in this option, in this alternative, he get maximum weight. Maximum weight means he getting much more attribute, positive attribute, and he getting much he getting lowest negative attributes, mean cost attributes. So that is why Topsis considered that Ali should need to visit Hunza.